My name's Peyton,
My name's Declan, and this is the Thermodynamics Review section.
Thermodynamics is the branch of physical science that deals with the relationship between heat and other forms of energy, and by extension of the relationships between all forms of energy.
This is an example of an isobaric process. The tin can contains some water, and when it is heated, steam escapes through a hole in the lid. When the can is flipped upside down into the water and the hole is submerged, there is a rapid change in temperature. This creates a vacuum within the can, causing it to implode. This happens because the hole is blocked, so pressure cannot change, causing the volume of the can to decrease, allowing pressure to equalize.
An isothermal process would be portrayed by this graph. In the process, the pressure and volume both change while the temperature stays the same. This causes the curve in the graph.
An adiabatic process occurs with no transfer of energy or matter between a system and its surroundings. Energy is only transferred as work.
In an isochoric process, the volume stays the same while the pressure and temperature change.
Kinetic theory of gases makes assumptions about gases to better explain their behavior. It describes gases as a large number of submicroscopic particles in constant rapid motion. There's a randomness in collisions between the particles and their environment, and all collisions are perfectly elastic.
The ideal gas law is the equation of state of a hypothetical ideal gas. It is an approximation of the behavior of many gases under many conditions. 1 mole of an ideal gas will occupy 22.4 liters at STP.
The first law of thermodynamics is the law of conservation of energy. It states energy cannot be created nor destroyed, but simply change forms. This can be expressed by delta E equals Q plus W, where the internal energy of a system is equal to the sum of the heat produced and the work done on the system.
The second law of thermodynamics states that the total entropy of an isolated system can only increase over time. It can remain constant in an ideal gas, where the system is in a steady state of equilibrium or undergoing reversible process. It is expressed by the equation entropy equals delta Q over T.
The third law of thermodynamics states that as a system approaches absolute zero, the entropy of that system approaches a constant value. The entropy of a system at absolute zero is generally zero.
Thermodynamics consists of PV diagrams, the three laws we discussed, kinetic theory, and the ideal gas laws. In conclusion, thermodynamics is the study of how heat interacts with other forms of energy.